Okay, so in this problem, we've already calculated the parallel force of gravity acting down the plane, the dynamic force of friction, and the static force of friction. So the first question is, will the block stay on the plane if it's initially at rest? Okay, so to answer that question, you're going to compare how big the static force could be to hold it on the plane and how big the parallel force is acting down the plane, right? So in this case, the answer to that is, will it stay, right? Will it stay? And in this case, yes, and that's because the force parallel is less than the force of friction static, the maximum, right? So I would say in my answer, I would say that the parallel force, the 25.51, is less than the 0.72, or if that's what it rounds to, right? This guy's bigger, this guy's smaller than that, right? Okay. Now the second one says, what if it's sliding freely down the plane? Freely. Okay. Freely means that means that there's not like an external force acting on it, right? Okay. So if it's sliding freely down the plane, the only forces acting on it are the parallel component of gravity, which is 25.506, right? And if it's sliding down the plane, I always have to draw these little lines there to remind me which way it's going. The force of friction, the dynamic friction, not the static. Static is, if it's sliding, static is history, right? All those little bonds have been broken, and it's this guy. It's the 5.301 newtons, okay? Now, everything down the plane is negative, everything up the plane is positive, so we're going to make this guy positive, this guy negative. Our F equals ma looks like okay, and then I go plus 5.301 equals 5.2 times A. That's how it goes. Okay, so let's see. Parentheses, negative 25.506 plus 5.301, right parenthesis, divided by 5.2. Negative 3.88557 meters per second squared. Now what this means is it's an acceleration down the plane. Okay, it's not actually decelerating. In fact, this thing is going faster and faster, right? It has a negative velocity and a negative acceleration. Okay, so the velocity and the acceleration are in the same direction. This thing is going faster, but it's going down the plane. Yep. All right.